In the previous video, we looked at multiplying rational expressions. In this one, we're going to be looking at dividing rational expressions. We can see we have the division sign, so there's a special thing that we need to do before we can go ahead and simplify this. We also need to recognize what we have. So as we can see that these are not all being multiplied together. We actually have a expression in both the numerator and the denominator because we have addition and subtraction happening between the terms. And so we also need to recognize that this here, in fact, is a quadratic, as well as all of the other terms in the numerator and the denominator. These are all quadratics. So the first thing we want to do is we want to simplify before we do anything else, and the way to do that is with quadratics we like to do our favorite thing, which is factor. Okay? So we're going to factor all of these quadratics. Before I do, though, however, I want to make sure I set it up as a multiplication problem. And I'm going to do that by simply changing my operation. So I'm going to change the operation from division to multiplication, and I'm going to flip the fraction that follows the operation. Okay, so let's do that first before we go factoring happy. My first fraction is going to stay the same. So that's going to be x squared plus 8x plus 7 over x squared minus x minus 12. I'm now going to multiply. I'm going to take what was in the denominator and I'm going to put it in the numerator. And what was in the numerator, I'm going to put in the denominator. So I flipped the fraction that follows the division. Okay, so now that I have it set up as multiplication, I'm going to go ahead and factor each numerator and denominator. So when I factor this numerator, I get x plus 7 times x plus 1. When I factor this denominator, I get x minus 4, x plus 3. When I factor this numerator, I get x minus 4 times x plus 2. And when I factor this denominator, I get x plus 1 times x plus 2. So I can see I have a number times a number times a number times a number. It's all really numbers being multiplied and divided. In fact, I can actually extend this division line to go all the way across. So it's just a bunch of numbers being multiplied on the top and the bottom. Okay, so I can go ahead and simplify. So I'm going to look for the same number on the top and the bottom. That's the same number in the top and the bottom. That divides out to 1. This is the same number on the top and the bottom. That divides out to 1. And this is the same number on the top and the bottom. That divides out to 1. So when I simplify this expression, I'm left with x plus 7 divided by x plus 3. But I have to remember, with rational expressions, I have to look for restrictions on x. So restrictions is where x would make the denominator equal to 0. Okay, so I cannot have my denominator be 0. So the first easiest place to look is right here. Okay, which came from this denominator here. So actually I'm going to back up a little bit, and we're going to look at just the restrictions for our first fraction. So our first fraction, in our denominator, we had x minus 4 and x plus 3. So notice I am actually looking up here at the restrictions in that denominator. So that would mean then that x cannot equal 4 and x cannot equal negative 3. So those are two restrictions from that denominator. So if I look for my restrictions in this denominator right here, that was our factoring that came here. So that's our x plus 1, x plus 2. So that means that x cannot equal negative 1 and x cannot equal negative 2. But we have to be careful. We have one more restriction, and that comes from our original way up at the top. So if we look up here, we have this denominator here, which happens when we flipped it, turned into our numerator. But there's still a restriction here, so we have to be careful. We have to remember the restriction in that very, very, very beginning. I'm going to make that a slightly different color. Okay, so that means we're going to look at the factors of our numerator here. So our factors of our numerator here were x minus 4 and x plus 2. So that ended up being x cannot equal 4 and x cannot equal negative 2. Fortunately, those were already claimed. They got divided out, but we always check just to make sure. So these here are my restrictions. We don't need to say them twice. So those are the values that x cannot be. So my final answer would be x plus 7 divided by x plus 3, where x cannot be negative 3, negative 2, negative 1, or 4. So that would be my final answer for that problem.